Welcome to today's webinar series with Dunkermotoren to the Smart Factory. Today, I would like to introduce our today's speaker, Markus Weishaar. If you have any questions, just leave the questions in the chat and we answer it in the Q&A session in the end. I would ask you to mute your microphones and now have fun with the webinar of Markus Weishaar.
So hello everybody, a warm welcome to everyone as well from me. Thanks to Janina who supports me here in the background and also helps me later on with the questions and answers that are placed in the chat. And today I will give you an overview about the industrial IIoT and the possibility and the new horizons this gives for our smart motors. I hope it will be an interesting half an hour session for you and gives you an idea where the way of Dunkermotoren goes and what's our ideas that we are follow. So first of all, a short introduction to me, who I am. I am Markus Weishaar. I am responsible here at Dunkermotoren for the topics Industrial Internet of Things and also for service and programming of our motors. My topics therefore are digitization, software, automation, and also let's do IoT and come together with you to good ideas and good solutions. I want to start with the world, how it is today. I think I'm quite sure every one of you knows like it usually looks alike in factories, in machines. There are motors, drives as on the field level as field devices below a controller, a PLC, and they are communicate usually via bus technologies like CAN Open or Profibus or industrial Ethernets like Profinet, EtherCAT, Ethernet IP to the PLC. The logic is programmed in the PLC, and in some cases, the PLC also delivers data to an ERP system like SAP or to a manufacturing execution system to control the processes behind. In really less cases, there is also an internet or remote connection to the PLC that allows to diagnose the PLC, but nearly not beneath it. And so if you want to have diagnostics and remote support on field level, that's usually be done via TeamViewer, two technicians on both sides, one who connects to the field bus, another one which connects with his computer to the computer of the technician on site, phone connection beneath them. So it's not that intuitive and that easy. So in the world today, we see there is no direct transparency to the field level. Usually it has always been done over the PLC, and there you just get an aggregated view of the devices, not an really on the device view. And also the remote support of field devices is difficult because there is no standard communication path. It's usually not connected. And that's the point where we starting with our technology. So where we see there are much improvements possible. So therefore, first of all, why IoT? Why do we go the way to the industrial Internet of Things? What's our idea behind or the targets we are challenging? So the first is to enabling remote functionalities like firmware and software distributions to single motors. So downloading a new firmware to one single motor or changing a motion code software that is running on the motor or just a parameter set, or do this for whole fleets in the field if they want to be or they has to be updated, a new software functionality has to be rolled out. Do this in regions, in machine-wise, type-wise. That's a functionality that we see in this field. We also see the field to have real-time oscilloscope, cloud-based, that you can directly start without first having a connection, starting a tool, establishing a VPN connectivity, where you just can do it over a cloud platform. And to cover all this, we see this under this condition monitoring topic, to have a view on the motors, what's going on, is there an alarm standing on, Is something happened to the motors? How does the values like temperature look alike? And so can react before something happens. Or even if you go to a field service, that you can therefore, before you go, collect the right tools, the right things you have to pick. You know what to do, you know the condition of the motor. Another point is that IoT enables an additional services to products. That means, like example, predictive maintenance. So we can calculate out of the data from the motor when the motor will fail, or if the probability of failure rises immediately from yesterday to today, for example, it increased from 40 to 90%, and then send a message, please inspect the motor, something has happened to the mechanic behind, to have an idea what's going on, and in the best case to avoid unscheduled stops and damages. That's a service we really see here for the future. And if you look a little bit more in the future, we also see motor as a service. So if there is a digital service next to the motor, why not include also the hardware in this service? And so you don't buy a motor anymore, you more or less lease the motor, and everything is in the service rate. And if something happens to the motor, Dunker will exchange it because of the data. We know what's happening. But to be honest, that doesn't look far to the future. So we would say with a range of between 5 to 10 years, I think then we will be somewhere in this direction, because this also is correlating with the business models of our customers. But it's a perspective that we see in the moment. And as a third pillar, we also see the support of service technician based on all these features to get the information to a motor directly to their smartphones, so that they can scan a code and then have all the needed and necessary information to diagnose the motor. What's the health status? Is there an alarm? What happened during the last 48 hours? And what the actual state, to directly can take actions or to say it's okay. What's the roadmap to reach all these goals? So our roadmap looks like this, and step one here is definitely to first have all this connectivity, connect the smart motors to the Internet of Things, and make them connected devices. And next step, bring the device cloud in the background alive, that enables, or that is more or less the backend for all these services, where apps can interact with, where data is managed, where data is stored, where with the data can work. And also bring apps to the market at this stage. And in the second stage, in the third stage, also bring plug-in services that directly can integrate it via API integration in customer solutions. So Machine Builder has an IoT solution to the end customer. He can integrate our services directly via an API integration, or can consume a digital twin of us, which provides all the information around the motor, like specification, drawings, manuals, and also live status. That's the way we see, and which we are following. So it goes from connecting over monitoring up to analyzing the motors. Of course, we can't go this way alone, because industrial Internet of Things in less cases works if everyone goes alone, because it lives with connectivity, the interaction between different systems. And that's the reason why we already are proud members of the Open Industry 4 Alliance and also the MindSphere World, to set on open standards, common solution, and work with strong partners like SAP, like Gepard, like SICK, and all the others which are in the alliance, to work together for good solutions. First of all, I want to start with smart motors and give idea what do we understand under smart motors. And here we start with the quote that we believe that the field devices become more and more intelligent, and also can take over more and more tasks from the layers above, so e.g. the control level. What does this mean? So here you see a motor of us, and there we see a smart motor for us is if the DC drive is directly integrated to motor, and so all the electronics, all the logic is in the motor and makes it therefore basically intelligent. Also, we see that the connectivity already comes with the motor. So the motor is able to talk CAN open, Profinet, EtherCAT, Ethernet IP, and therefore is able to talk to other instances like PLCs or edge gateways. Also, safety is integrated so that the integration directly can be done with safety PLCs, with safety logic, and nothing else is needed between. And a last thing is the free programmable part of the motor in C that we call motion code. That means that the motor can directly program like a PLC with different code that reacts in real time with the motor and performs action on the motor. With these features, motors can be linked to networks, and the logic of a machine can be built on the motors, and then it can be linked with the process level over gateways, over connection devices, and then there is no separate PLC needed in the highest level, or just a little bit monitoring can be realized next to the logic of the motor. And there, if you're interested in this topic, feel free to join also the other webinars where we have a deeper view what's possible with motion code and where the way goes there. But now, how does the IoT opens new horizons for these smart motors? There we see with IoT, the world of smart motors gets even more transparent and makes the data that is already available of the motor, that is delivered every second from a motor device, gets usable. And what do we mean with that, or what's the world, how we see it? I think this is a picture every one of you will know. So there will is this little helper that is in the pockets of your trousers and that helps you during the day with intelligent or less intelligent applications, that supports you by reading mails, by booking flights, by checking your bank account. And we see that is the future where also the industrial segment goes. And why do we see this? I think a good example here is the weather app. I had some good interview partners that told me their children just look on the smartphone how the weather is and don't look outside the window. So to be honest, I prefer to look outside. But what is the idea behind? The idea is, why should I walk somewhere and look what is the condition if the data is permanently and already available in the cloud? I think for the weather app, it looks fancy, but if you think about machines, then it's quite interesting. Why should I walk half an hour through the facility or fly around the world to checking data of a machine, of a motor, if I can do this with my smartphone or with my computer directly from my desk? And that's the reason why we believe also in the industrial segment, it will go in this direction. But what does it mean? Does it mean every end customer has a Dunkermotoren app and monitors his fleets of motors? We don't believe like this. I think the factory operator is always interested in machines, in his facility, in his factory, and not at the motor if the motor doesn't do any problems. Of course, the motor gets interesting if it interacts with the machine and it influences the status of the machine. And that's the way how we see the world, that we deliver information about the condition of the motor directly to the machine builder, that he can work with this information, integrate it in his customer solution, IoT solution, and so therefore has a more complete build picture of the machine. And how does this looks alike in our idea, or also discussions with many other vendors? So we see the machine builder has a cloud backend where he works the data of his machines, where he aggregates it, where he makes his analytics on. And also the component vendors has their own cloud backend where they collect the data of the devices and aggregate the data, take the informations out of it and deliver the final fully analyzed information to the machine builder, so that he has, on the one hand, not to build up knowledge about drives and don't have to think about how to interpret the data of the drive. And what's here the background of this? Why should I, as a machine builder, have a look on the drive if I can already get this information from the experts? And I think we are the best expert for our products to make the diagnostics, to say what's wrong with the product, what's the value inside the data, to provide this to our customers, to the machine builders. So therefore, a little bit a deeper view. How does it work? How does such an infrastructure looks like? There we see 3 different ways. One way is an fully integrated final done solution where we send the gateway with all the necessary software on it, and that collects to a cloud. But we don't think that that will be the future. We more or less say this middle way here next to me, that will be the most probable future, where a factory operator or a machine builder provides a gateway that is able to carry software from vendors. And there we deliver a software gateway based on Docker, delivering data in MQTT or OPC UA, connecting on the bottom side to the motors, and so provides data on one day if just a local data aggregation is needed on the edge level, so on this gateway, on this factory level, or in a second case, provides it to the cloud. What can I do with such a solution? Now the data is on the cloud, so nice, I can watch them there. But the interesting is that if you also see the end devices. With I told about the smartphone of the service technician, he can scan a code on or next to the motor, and with this identifier he can log into the cloud and getting all the informations about this motor. What's happened to them, what's an operation hours, what is the exact type, he can request support to this device. If you think more in a desktop computer, there you can manage whole fleets, you can manage firmware rollouts and all this stuff to your devices in the field. And you see it here in the middle, you also can do an integration to this cloud backend over an API, and so can integrate the information and the services from the cloud backend in your own application. Where we are and what we are doing here in the moment, we are building up this device, this cloud backend, and here we set on a strong partner with Siemens. We build up this ecosystem with the Siemens MindSphere and also benefit from their experience in the industrial sector and have quite valid and trusted tools that brings a lot of good also IT security functionality with him, and we have an out-of-the-box solution to build our own applications and our own backend. I've talked a lot about the edge. I think it's also an important point in this discussion because not everything happens in the cloud and not everything has to go to the cloud. So therefore, the edge is a really important part in this picture, which means data should be handled close to the creation, so close to the motors, that not this big amount of data has to be delivered to the cloud. And also there you have a low latency because you are close to the sources of the data. And that's the reason why the edge is important. Also, a lot of people are today not willing to work in the cloud. They just want to work local. So we also have possibilities to bring the software on an edge level, provide data there, doing local analytics like detecting anomalies or having local OPC or A server to have more functionalities of our motors. That's also one part of the medal around IIoT. So in short words, so it's the gateway between the shop floor and the IT or the cloud. So it's also an integration, for example, in local asset management systems, in MES systems, or in general in local IT systems. And we see the edge as an app layer for the shop floor to close the loop to the smartphone apps. Before we say on an edge level is that if that is created on an open technology, it allows to run different applications from different vendors. And so next to the motors also have, for example, a piece of software that connects sensors, that connects the machine, and so have different apps and functionalities close to the data creation. As mentioned, it's a data aggregation and a data creation, and it delivers local analytics and data provisioning on an on-premise level because we have low latency there. In general, I have also mentioned IIoT doesn't work alone. We see also an open architecture of such a solution as the key. Here I want to take the reference model of the Open Industry 4 Alliance, which also fits our ideas, our understanding. So we have on the bottom the real field level with all the existing and also in the future existing field buses. We have an edge layer where different vendors can place their applications, their software containers. They can exchange data via MQTT. The containers itself are based on Docker. Then we have on the third level the local IT or the local cloud environment of the facility operator, of the machine builder, where he has the control what happens with the data, where is the data flow, which information can go to which source or from which source to which destination. And on the highest level, we have the different backends from all the vendors where the services come from. And how does we fit in these pictures? Of course, we already now have the motors that are able to be connected to an edge via Provinet and can open, and there provide the information via OPC-UA or MQTT. We have containerized apps on a prototype level that allows to read out the motors and provide the data on this edge level and also connect it to some clouds. There we have done already some prototype integrations to Microsoft Azure, to the Cumulosity of the Software AG, and of course to MindSphere. And now we are building up this IoT platform from Dunker based on MindSphere, where we can provide device management, AI algorithms to go the direction of predictive maintenance, and also provide additional information, specific documents to the drives, where we also have one development direction to the platform Industry 4.0 asset administration shell. As a last point, where we're also working on, that's the plug-in apps and services, that these functionalities we build up on MindSphere can directly be consumed over API as a service, where we see as a next step predictive maintenance, monitoring, and this handling of the motors. Here above me, you see a prototype implementation of us. That's our IoT demo case, where we have realized a cloud-based dashboard of our motors that shows life value of a motor. And if someone is interested, we can, of course, organize a demo of this prototype. So, short summary, what is in our point of view the benefits of IIoT? It delivers the full transparency of the field level, not just to the PLC. It gives the possibility to do remote diagnostics for intelligent field devices. You have the chance to avoid unscheduled issues. And of course, if you think about motor as a service, there will come up new ways to use and buy motors. And you see it in these pictures together with motion code. We see, for example, AGVs, so automatic guided vehicles, and also modular designed machines as an interesting area for our technologies. And again, request if you're interested, come also to our motion code webinar. So as a last conclusion, I can't just say, let's do IIoT together with us. If you want to be one of our pilot customers, feel free to contact us. So we are quite open in the moment for each project. You can go the way together with us, and we can do cool common things. Also, a remark to the 11th of October. So be surprised what we will announce there. I just can say it will be an quite interesting and big information around Dunkermotoren and our IIoT developments. So be excited what we will provide there. And so we are now at the end of the webinar. I hope it was interesting for you. you had maybe some new ideas, and I hope also some interesting questions for me. And now I'm ready to answer your questions. There, the benefit, of course, is that we can have a deeper view inside the motor than it is possible from the PLC. And we also can link the data, so we can get information out of the data and not just the data itself. So if the motor is connected to the PLC and the data is delivered there, the customer has to do all the work on the data and the interpretation of the data by its own. With our solutions, we can help him with interpreting the data, and then it doesn't just end somewhere in a data garbage. That's, I would say, the main difference.
So, are there more questions? Feel free to ask your question now directly to Markus. Unmute yourself, and if there are no questions so far, feel free to write us an email, and yeah, we will answer them. And we are looking forward to welcome you in our next webinar, Motion Code. And yeah, if there are no questions so far, I would say thank you very much for being with us today. And I will give the word to Markus now.
Yeah. Also, thank you from my side. I would be glad to come in touch with some of you, so feel free to use my contact data behind me and write me a mail or phone me. So then we also can have further discussions around these topics if one of the topics is interesting for you. And so thank you very much for your attention today.
Thank you, Markus.
So then thanks again to all of you, and I wish you a nice evening today, and enjoy the rest of the day.